Hi everyone, we're going to find the radius of convergence and interval of convergence for our series here. We're going to use the ratio test and find out what we get. So let's use the ratio test, and that means the limit as n approaches infinity of a sub n plus 1 divided by a sub n. Alright, this is going to equal the limit as n approaches infinity. We take our series and add n plus 1. Alright, and then divide by a sub n, and that's like multiplying by the reciprocal. So this is going to be times 2n minus 1 divided by a sub n. Alright, now this equals 2n plus 1. So basically when you simplify this, we're going to get the limit as n approaches infinity, and we're going to get absolute value of, not absolute, we don't need to do that anymore. We're going to do 2n minus 1 divided by 2n plus 1, and then we're left with, you reduce this, that's just going to be absolute value of x. Alright, now going further, we're going to take the limit as n approaches infinity and divide each of these pieces by n. That's going to give you 2 minus 1 divided by n, divided by 2 plus 1 divided by n, times absolute value of x. Now this is equals 1. So we're left with absolute value of x. Alright, so by the ratio test, the series converges when our absolute value of x, this is what we want, condition 1. I know it's hard to see. This is your limit, but this must be less than 1. Alright, so now we need to find the intervals of convergence. So for the intervals of convergence, we're going to compare it to our series n equals 1 to infinity. And this is going to be when x equals 1. So when x equals 1, we're going to get 1 divided by 2n. Now, since 1 divided by 2n minus 1 is greater than 1 divided by 2n, and also that 1/2 times the sum of n equals 1 to infinity is 1 divided by n, it's a divergent because it's a constant multiple of this harmonic series. Alright, so let's check when x equals negative 1. If x is negative 1, we get the series n equals 1 to infinity of negative 1 to the power of n divided by 2n minus 1. Now this converges with the alternating series test. Alright, this term is larger, the second term is larger than the first term, and our limit of this goes to 0. So for negative 1, it's convergent, so you're going to write it as a closed interval, and for 1, it was divergent, so that's going to be open interval. So this is your interval of convergence. Thank you. Have a nice day. Bye-bye.